I'd like to introduce Garret Cahill, Elena Vishnevskaya, and Carey Witkov for their presentation on remote teaching of differential equations. You guys have 25 minutes. I'll let you know at the 23 mark. Go ahead.
Great. Thank you, Anna. And thank you, Brian, for having suggested this panel discussion topic at last year's Simiode event. Thank you. So want to just give an overview that what we're trying to accomplish here is to have a conversation about some of the practices for teaching differential equations online. These are just practices in use, so we can't claim them to be best practices. We probably noticed there's been a trend for the years that people just call whatever they're doing best practices, and we're not claiming that. But we just want to discuss some of the things that are in use in teaching differential equations online. All online courses have some things in common, but there can be some course-specific factors that might be unique to teaching differential equations online. So we want to be able to have a discussion about that as well. As Anna mentioned, we have 25 minutes and can only touch the surface of this. So, our goal is to have a conversation about it. And we recognize that over the past few years, many of you have gained experience with remote teaching. So you've got your own stories to tell, and we'll try to save some time at the end for question and answer. The panelists, Anna introduced, Garret Cahill from University of Massachusetts, Amherst, Elena Vishnevskaya from Embry-Riddle Worldwide, and Carey Witkov, also Embry-Riddle Worldwide. And it's sometimes just helpful to form a mental map of the discussion topic. So we wanted to have two maps here. One, how differential equations occur in remote courses, and it runs a spectrum. So on the left side, you can have a dedicated differential equations course, which often occurs with linear algebra. Garret has experience in that type of differential equations course where differential equations are the main focus. And then you could have differential equations occurring in a significant portion of a higher level math course. It could be applied math, mathematical methods, something else. And Elena has experience with teaching differential equations remotely in that context. Or you could have differential equations just as they occur in a science and engineering course. For example, physics, which is my experience teaching physics remotely, and where differential equations occur. And there, of course, the focus on differential equations is least in terms of the total perspective of the course. Another thing that's perhaps a little bit helpful is just to take a look at the range of possible remote course structures. You can have synchronous courses, which have fixed Zoom meeting times. And this is essentially a regular differential equations course, but instead of meeting together in a classroom, everyone meets together perhaps on Zoom or some other video conferencing. So it's similar then to an ordinary in-person course in terms of the time structuring. Or you could have an asynchronous course, so weekly deadlines. And this could be huge, like a MOOC, a massive online course. Or you could have, again, something like a regular differential equations course taught online, but asynchronously. And my experience with teaching physics remotely has been in the asynchronous format, or you could have some hybrid combination of these. So what I'd like to do is, with limited time, I've got a few questions, and what I've done is combine some parts of the questions together, so they're kind of hybrid. That way we don't bounce back and forth too much. And just this being Super Bowl weekend, instead of saying, let's start with the first question, I'll say, let's kick off with the first question. And maybe we'll go in alphabetical orders as listed on the panelist sheet. So we'll go to Garret first with the question of, to describe the type of remote differential equations course you taught or are teaching, your overall impression of the experience, and whether you find teaching differential equations online, is it really that different from teaching differential equations in person? And maybe I'll stop sharing so that then you'll be able to attend directly to the panelists as they speak.
Great, thank you, Carey. Yeah, so my first experience teaching differential equations online was forced in the spring of 2020. And so my approach then was definitely a lot different than I do now. I would say in the beginning, I had kind of had a hybrid of synchronous and asynchronous, where there would be lecture videos that students could watch, but there would also be set meeting times when I would hold class as I usually would in person. But after going through that experience and now teaching just dedicated online courses intentionally, I do more of an asynchronous and hybrid mix. So I have a lot of students that are taking online courses because they're in a different time zone, or they are working a job during the summer, during the winter, or an internship, something like that. So I do create lecture videos and things like that where students can completely do the class asynchronously. But I found that there's a lot of students that like having that synchronous connection and like being able to ask questions in real time. And so we also added in these synchronous components where we formed study groups, and students would have 2 times a week that they could meet with their study group with either myself or a TA facilitating, and they could ask questions, we could work on problems, all of that stuff. I would say that you couldn't complete the course completely synchronously, just we didn't cover all the material in those synchronous sessions, but the class could be done totally asynchronously if a student wanted to. To the question about, the difference between in-person teaching versus online teaching, I think that's a really interesting one. So much so that even before I had this conference on my radar, I asked it to my students last semester. I teach this class in person, but because I've developed the asynchronous material for the online class, I let my students use that if they choose to. So I would say out of like a 60-person class, I usually have about 40 people that attend and about 20 people who choose to keep up asynchronously. And so I asked the students last semester, why are you showing up in person? What are the things that you're getting out of the synchronous in-person lecture that you wouldn't get from these asynchronous online lectures? And some of the responses were kind of expected. They like being able to ask real-time questions as they're learning the material. They like to be able to ask us. They like having the scheduled time where every time at Monday, Wednesday, Friday, 10 o'clock or whatever it happens to be, they're at this differential equations class. And if it's asynchronous, it's hard to keep up. But then there was a lot of other ones that maybe I was expecting a little bit less. One of which being, they just like being in the classroom where they can talk to their peers and they can talk to the instructor. One student said they come to my class because I'm nice to them. They have another class with this option and they don't show up because it wasn't, such a comfortable class for them. And so I think as we move more things online, we want to be mindful of those things that they are missing if they choose to be learning online. And those were some that my students had brought up last semester.
Thank you. No, that's so helpful in hearing the adaptations that you make in teaching differential equations online to provide the still kind of engaging experience with students. Yeah, so Elena, just wondered your thoughts on this as well.
Hello, everyone. Well, my experience may be not as broad as all yours. I have taught only one class, not one time, but just one class. It's the same class. Several times I taught that class, and that is a graduate level mathematical analysis, purely online. So there were no Zoom meetings, no face-to-face meetings. It's just purely online. And I have to say that teaching graduate level students is much easier than teaching undergraduate students. For many reasons, but one reason is, I think, it's one of the important reasons for me, is that students want to be in a class. You do not have to pull them here and explain why they need to learn what they are learning in this class. So all my students were disciplined, enthusiastic, interested, and wanting to learn. And maybe one student I can remember, maybe two maximum, that actually struggled and needed my help on a weekly basis. And all other students were ahead of time, submitting very good work. As far as the content, to say that course was condensed course. There were essentially overview of 4 different courses, which was a Ds, ODs. We had the vector, we have complex analysis, and we have Laplace transform. So it was 8 weeks combining everything. So so differential equations, I think we covered for the first 2 weeks, and that was it. And I have to say, I taught that class in several different formats, in a way that I was given that class to redesign, redevelop that class. So my first approach was, let's give them a couple of assignments every week. There's discussion question, there's something hands-on that they can do. And I soon realized that's just too much. What the students are doing, it's a busy work. They're just rushing through assignment to assignment, not producing anything meaningful. So my latest approach was to get 1 assignment per week and give the other week something bigger as a hands-on project, as something they can model and run a MATLAB code. So the MATLAB project would be over 2 weeks. And this is where students were given an example, they're given instructions what to do. They would organize their work as a live script and submit as a live script to me, and I could ask questions, and they have to write a report on that, what they have learned, and answer a couple of questions that I ask. So you have to write the program, they have to solve this equation and answer a couple of questions. So I thought is very good. I had very good reviews from students. They said it's not busy work. They've learned things that they didn't think could be used. As for discussions, we had, I think discussions could be removed, or I think at a graduate level discussions really didn't work very well. So just to keep it very short, I think students appreciate an opportunity of having hands-on experience in maybe a MATLAB, maybe different software package environment where they can actually simulate, run application and learn from that. And making mistakes is actually good because they know why they made a mistake and how to correct the mistake.
Very good. No, thank you. Thanks for emphasizing the difference between remote teaching graduate students versus undergraduate in this context, and also how you're able to try to prevent the kind of like assembly line approach, which can happen in remote instruction, where students just doing assignment after assignment after assignment to complete the course, but there might be less engagement. You're able to overcome that. I'll just mention one thing regarding that question as to whether there really is a difference teaching differential equations online versus in person. It sort of reminds me a little bit of Niels Bohr's concept of complementarity that he introduced for wave particle duality, where he said that sometimes you can have two mutually exclusive but together exhaustive things true at the same time. And I feel the same way where, yes, on the one hand, there is a difference because one's online and one's in person. But on the other hand, no, there's no difference. This is differential equations. You still have to learn the same subject. So those two can both be true at the same time. For the next question, I'd like to ask you about the resources that you've used or would use. I know, Elena, you touched on this with MATLAB, but what resources, computer software, apps, instructional materials, textbooks did you use for remote teaching? Were they helpful? And what would you consider using next time? And would that include AI?
Oh, I'm a fan of MATLAB. I think it's a powerful tool, definitely, not just at teaching at the graduate level, but definitely on undergraduate level. Using that tool assumes that students understand what programming is and how to program, how to write short scripts. So students will need some sort of a preparation. As far as books, I do the course that I have taught was based on a book by Krejcik. I just can't remember. Yes, it's a very thick book.
Advanced engineering mathematics.
Yes, exactly.
Yes.
That's the thought. Yes. Yeah, so it's pretty much, yes, but certain chapters were extracted from that book, so we didn't cover the entire book. It's a really large book. I did suggest some supplemental material on MATLAB particularly, with some good examples. I could include the link in the text chat in a moment if interested. Yes, we had pre-recorded videos, but they were really just how to work the particular problem on the board. And I don't think there's a shortage of those videos, really.
Right,
and
right.
There's
Yes.
just so many. Did I answer the questions, or
Yeah,
I missed something?
Absolutely. Yes, thank you. Thanks so much about resources you've used. And Garret, what about in your classes?
So in the creation of the lecture videos that Elena was talking about, so I did make those for my class and used Camtasia for that, which has a lot of great features. You can put in captioning. One thing that I really like that I can do, thinking about differences that I can do online versus I can't so easily do in person, is I can put links in the videos to outsource some calculations. So say we're doing a Laplace transform problem or something like that, where we have to put a quadratic into vertex form. Now, if I'm in the classroom, I don't want to lose students and just kind of jump to that vertex form, and I'll do the steps out to get there. But in my online lecture videos, I can just kind of put a little link and say, if you want to see the steps done out of putting this into vertex form, you can click here, and I'll kind of bring them to a little side video. So that is one nice thing where I can kind of keep the focus on the topic that I want to do and not have it get too cluttered with some of the algebra that I just don't have the option in class. So that's one thing I really like. I'll also use WebWork. So the way I put together my lectures is I'll have a lot of short lecture videos. So, what I might do in 50 minutes in the classroom, I might have split up into about 5 or 6 shorter 7 or 8 minute videos, something like that. But I'll also use embedded WebWork problems so that kind of partway through, students can practice some problems. Like I may have them pause in the classroom to practice a problem instead of me just doing it. But with web work, I can allow them to kind of do that in the lecture page to simulate that a little bit. I do love the idea of using something like MATLAB and have kind of student side using more technology. Though I'm not sure I'm ready to go to that yet, having an undergrad group. A lot of them are well-versed in programming and being able to do loops and things like that, but a lot of them are not yet. So I love that idea, Elena, and I want to think about how I can kind of incorporate that a little bit more. I also saw one of the upcoming talks today is on slopes, which I just started to kind of play around with. So I'm hoping to get some ideas from that and try to think of some more things I can bring in to my class.
Yeah, no, thank you, Garret. In fact, I just sharing a slide now of a few resources for remote teaching differential equations. For books, there's the excellent Differential Equations, a toolbox for modeling the world. Dr. Kurt Bryan, who's giving a talk. I forget if that's today. Have to check. That's notice the link at the Simiode website. Also, there's a nice notes on DiffEQs, Differential Equations for Engineers, by Dr. Jerry Liebel as well. For software, the Slopes app that you mentioned, which Dr. Tim Luke is also going to be presenting at this conference. And of course, even Wolfram Alpha is quite useful for differential equations as well. Well, I have more questions. However, I want to leave time for questions and answers. So perhaps why don't we do that, and then we'll see if need to ask additional questions. Let's see. Oh, so I see in chat. Okay, great. So let me just open the floor for questions that you might have of anyone for any of the panelists.
I will have a question. I'll start with a comment and then morph it into a question. I just started using replacing one of my exams with Simiode projects, and I'll put the students basically completing the Simiode project and maybe doing a class presentation. And I think something like that is a viable option for replacing exams, but I was curious, what were your experiences in running exams with your online courses? Did you just eliminate them somehow, or did you just do them traditionally?
Thanks for asking this important question, Jenny, about assessment. And yes, maybe starting with Garret, what has been your approach to that?
Yeah, so I'm semi-skeptical of our approach so far, but we've been using a proctoring system called HonorLock for students taking the exams, and we do still have exams in our class. We have 2 exams for the class, a midterm and a final. The one thing that I do like that UMass has done is made a requirement that students have to pass on average the final and the midterm in order to pass the course, just because it's the one time that we kind of know taking the exam is the person enrolled in the course.
I see. Thank you. And Elena, anything about assessment from your perspective?
Yes. Just looking at, just refresh my memory of what we had done. I had 2 exams scheduled, and there were about 6 application-based questions in the exam. Everything was purely online. It's not through Canvas. Students had to write their work, scan and submit, kind of old-fashioned. And I did my best to change questions twice a year for that exam.
Very good. Thank you. Thanks. Greg, I know we're running out of time, but if you maybe a quick question, I know you've had your hand up. Or you may be muted.
Yeah, sorry. Thanks. Garret, I also use WebWork. I'm teaching differential equations in the summer. and I've been using the same WebWork sets for, I don't know, way too long. Did you develop your own? Because I'd love to like get ideas on how to make mine better, and like how did you go about making your WebWork?
Yeah, I did develop my own for the most part. And I don't think I've developed a lot that would be necessarily great for homework problems. I made them more tutorial in style, where there'd be like 3 or 4 parts to a problem, because I wanted to supplement the lecture. Like, first you would do this step, then you would do this step, and then you do this step, and kind of guide them through a little bit.
Love it.
Very-
Yeah,
very-
we should chat because I think that might work well for my particular, and but I'd also Elena, I also want to get into MATLAB. I want to do everything, but MATLAB I'd love to do. So if you could share that, you had a link you thought you might share?
I don't have a link because I can't remember how I downloaded the book. It's the book I use as a supplemental. It's I put in the chat already. It should be there.
Oh,
Great.
sorry. Okay.
Great.
Yeah.
All right.
Thank
Thank you.
you. Thanks so much. And I'm sorry, Brian and Anna, that looks like we went over a minute or so, but thank you very much. Thank you to the panelists, the participants. Thank you all.
So just a point of clarification, this session can stay open. Anna and I, Carey and Garret and Elena have privileges that they can keep it going. And so if you want to keep talking, that's fine. We need to go on to monitor another session. So keep telling stories, and that's the point here. We don't have to close it out. And I guess, Anna, I'll turn it over to you to close.
That was exactly what I was gonna say. The session after this, I think, is just a get to know each other in small groups, which is sort of what you're all doing now. So if you would like to keep this room open, go ahead. I do have to leave. I have to move on to another place. But thank you all for speaking and asking questions, answering questions. It was wonderful. It was nice to hear from everybody. So thank you.
Thank you. Thank you all.
Thank you, Anna.
Thanks.